Welcome to our deep dive into the fundamental principles of radiobiology. Today, we'll explore how radiation interacts with biological systems. Radiobiology is a fascinating field that examines the effects of ionizing radiation on living organisms, from molecules to complex systems. We'll cover several key principles that are crucial for understanding radiation's impact. First, let's look at the law of Bergoni and Tribundo, a cornerstone of radiobiology. This law states that the radiosensitivity of cells is directly proportional to their reproductive activity and inversely proportional to their degree of differentiation. This means that rapidly dividing cells, like those in the bone marrow or gonads, are much more sensitive to radiation than mature, differentiated cells. Now let's explore the physical factors that influence how biological systems respond to radiation. The total radiation dose and the rate at which it's delivered significantly impact the biological outcome. The type of radiation, whether it's alpha, beta, gamma, or X-rays, and its energy level, all play a role in biological damage. The presence of oxygen can also enhance the damaging effects of radiation, a phenomenon known as the oxygen effect. Beyond physical factors, several biological elements determine a cell's radiosensitivity. A cell's sensitivity to radiation varies depending on its phase in the cell cycle, with some phases being more vulnerable than others. Cells with a high proliferation rate and less efficient repair mechanisms tend to be more radiosensitive. Understanding dose-response relationships is critical for predicting radiation effects. Linear dose-response relationships suggest that the effect is directly proportional to the radiation dose, even at very low levels. Nonlinear relationships, on the other hand, indicate that the effect might be less pronounced at low doses, but becomes significantly more severe at higher doses, often with a threshold. Let's categorize different types of radiation and understand their linear energy transfer, or LET value. We'll differentiate between alpha, beta, gamma, X-rays, and neutrons, highlighting their unique properties and how they interact with matter. Linear energy transfer, or LET, quantifies the amount of energy deposited by radiation per unit path length, influencing its biological effectiveness. To summarize, understanding these fundamental principles of radiobiology is essential for predicting and mitigating the effects of radiation exposure in various applications.